4.2 Handling command line arguments with argparse. We're going to see how to create an argument parser object and how to tell it what the command line switches and arguments it should look for are. And then we're going to perform the next step of our project. Most command line programs, and a surprising number of graphical user interface programs as well, can be given extra information on the command line after the command that invokes the program. These extra bits of information are referred to as arguments or switches, and they are delivered to Python programs as a list of strings. It turns out that there's quite a lot of code involved in turning an argument list of strings into useful information, especially when we want to make the program as convenient for our users as possible. Fortunately, a lot of that code can be the same from program to program, and the Python standard library's argparse module takes care of much of the effort for us. The primary component of the argparse module is the argument parser class. In the minimal case, it only takes 3 lines of code to use argparse. We need to import it, create an argument parser instance, and call that instance's parseArgs function. As usual with minimal cases, it's not very useful. The only arguments that the program would respond to are -h or --help, either of which would print out an automatically generated how to use this program message and then exit the program. The first thing we can do to make the argument parser more useful is provide a value for the description parameter of its constructor. The argument parser's automatically generated help message will explain all of the arguments that the program expects, but it doesn't say anything about what the program is actually supposed to do, unless we provide the description ourselves. In this case, we've just put in hello world. In real cases, we would generally want to put more useful information than that. The next way we can improve the argument parser's behavior is by telling it the name of the program. If we don't provide a name, it will do its best to make a reasonable guess, but we're better off telling it ourselves. I consider the python-m command to be the canonical name for my own programs, so that's what we'll use in our examples. We set up the name by passing it as a string to the argument parser constructor's prog parameter. These changes make the program's output prettier and more useful, but they don't actually give the program any new capabilities. We need to start adding argument specifications to the parser so that it can check for them. We need to start adding argument specifications to the parser so that it can check for them in the argument list. We do that by calling the argument parser instance's addArgument method. Argparse recognizes 2 kinds of arguments, optional arguments and positional arguments. As the name implies, optional arguments are not required, but if the user chooses to include them on the command line, they have meaning. Positional arguments, on the other hand, are required by default, although we can modify that behavior. Optional arguments have names that start with a dash character, and can have more than one alternate name for the same argument. The names are passed as parameters to the addArgument method, as in this example, where -p and --print are alternate names for the same optional argument. There are a lot of ways of configuring an argument when we add it to the parser, which are detailed in the argparse documentation in the library reference on docs.python.org. For options like our print example, though, the important configuration items are the action and the default. The action tells argparse what to do when it finds the argument on the command line, and the default tells it what to do when it doesn't find the argument on the command line. The action parameter can be either a string containing the name of a well-known action, which are predefined and documented on docs.python.org, like store true, or it can be a subclass of the argparse.action class if you want to customize it for yourself. The default can be any arbitrary value, which will be stored as the value of the argument if it's missing when we actually ask the parser to parse the argument values. The other kind of argument has to have just one name, and it can't start with the dash character. By default, these arguments collect one word that isn't part of an optional argument from the command line, in the order that they were added to the parser. If we configure the argument using the nargs option, we can change the number of words that the argument collects. If we set nargs to a number, it will be that. If we set nargs to a number, that many words will be collected for the argument. We can also set nargs to star to mean any number of words, or plus to mean at least one word. There are a few other values we could set nargs to, but we won't talk about them here. Let's look back at our pipeline program. I think we want it to understand 2 arguments. An optional argument that tells it to keep going even if one of the programs returns an error code, and a file name where it should load and store the pipeline configuration. After the call to parse args, we have an object named args that contains a keep_going attribute set to either true or false, and a file name attribute containing a string. Notice that the attribute of the arguments object is keep_going, not keep-going. Python doesn't allow dash characters inside of attribute names, and argparse is smart enough to fix that for us automatically. If we wanted to set the name of the argument object attribute manually, we could have passed the name we wanted to the addArgument method as its dest parameter. That's D-E-S-T. Now that we've worked out how to read the information that's given to us when the program starts, so command line parsers are created with argparse.argumentParser. The parseArgs method reads the command line and generates an object containing the arguments. And parsed arguments do not have to be strings, they can be numbers, lists, and so on. In the next video, we're going to look at how to interact with the user while the program is running.